Hello and welcome to this Tetris Publishing video on querying SQL Server. I'm Adam, and in this session I want to show you how to carry out elementary calculations in SQL. Before we begin on the SQL, let's look at the topics that we'll be covering in this session. The first thing I want to look at is simple maths, and I mean really simple. Additions, subtractions, not very much more than that. Then I want to move on to calculating simple ratios and showing you how to nest calculations one inside another to give an order of precedence to the calculations. Then I want to move on to showing you how to sort data using the calculated output as the sort criteria. Then we need to see how to handle missing data, also known as null data, in calculations to avoid giving the wrong results. Finally, I want to show you how you can use calculated values to filter SQL result sets. Welcome once again to SQL Server Management Studio. To start this session, I want to show you how to write a very simple calculated query. The first thing to do, of course, is to open a new query window and ensure that it's connected to the Prestige Cars database. I'm now going to paste in a simple calculated query, and then I'm going to run it. This query is designed to list the total cost elements of all makes and models of car ever sold by Prestige Cars. It does this by using the Sales by Country view, as this contains all the required tables correctly joined together. Then it adds the make and model fields plus a calculated output field that adds together, for each record, the initial cost per vehicle. This is made up of the cost field, the repairs cost field, the parts cost field, and the transport in cost field. Let's look closely at the SQL itself. You can see that the fields are treated as if they were cells in a spreadsheet. Simply by using the plus character, you can add the value in a field to the value in another field. Only each time you're using the field name to indicate the value to calculate, rather than a spreadsheet reference. And of course, you're not limited to additions. You can subtract as well as multiply and divide, just as you would in a spreadsheet. And finally, it's worth noting that you need to add an alias to any calculated fields that you add to a SQL query, because otherwise there'd be no column name in the output for the calculated column. To extend the basic concepts, I'm going to replace this query with another one that illustrates how you can apply more of the fundamental mathematical operators in SQL queries. This new formula calculates a ratio, the ratio of all the costs to the selling price. Now it does this by adding up all the cost elements, cost field, repairs cost field, parts cost field and the transport in cost field, and it then divides these by the purchase cost. The interesting part of this piece of SQL is that it nests parts of the calculation inside parentheses. This is done to ensure that parts of the math are carried out before others. More specifically, adding parentheses around the cost elements guarantees that the fields containing the vehicle costs will be added together before the resulting figure is subtracted from the sale price. This gives a gross profit figure. Then, the ratio is calculated by dividing the gross profit by the sale price. So once again, any arithmetical calculations that are carried out by SQL look very much like their spreadsheet equivalents. I'll now run the query. As we take a closer look at the results, you need to be aware that the output is not formatted in any way. SQL Server returns the result, the ratio, as a value without any attempt at presenting the output. So what you see is a very, very long decimal figure. I now want to show you how to sort data using the result of a calculation. To do this, I'm going to extend the current query in two ways. Firstly, I'm adding the make name field to the select statement. Then I'm going to add an order by clause at the end of the query, and I'm going to sort the data on the alias that was used in the query for the calculated field. Now I'm going to run the query. Let's take a look at the results of this query. Here we can see the advantage of having SQL Server carry out calculations to so many decimal places. we can see instantly that the most profitable sales are at the top of the list, and as I scroll down through the result set, you can see that the profit ratio decreases. So this query works very much like the previous one, except now the results are sorted. And it's worth noting that the order by clause is the only place in a SQL query that you can refer to an alias that you added earlier in the same query. What I want to do now is to make you aware of a potential problem that you can encounter when carrying out calculations in SQL Server. First, I'm going to remove the existing SQL query from this window, and then I'm going to paste in a new query. This query simply adds together all the cost elements for every car sold. Now I'm going to run the query. And while I'm at it, I'll increase the size of the results pane so we can get a good look at the output from this query. The query results look pretty good so far, but let's scroll down to the bottom of this particular query set. Take a good look at the final record in this result set. This final record has no costs for the car. This is certainly very strange. What has happened is that one of the fields in the calculation, the cost field, the repairs cost field, the parts cost field, or the transport in cost field, contains a null in the place of a value. In these cases, SQL Server makes the whole result of the calculation a null. It's as if this single null pollutes the whole calculation. Now, in the case of this query, let's assume that I've looked at all the source data and I know that it's the parts cost field that's causing the issue. Now, there is, of course, a solution. That's what we're looking at. So let's apply the solution to the query. Because what I'm going to do is to add a new function, the isNull function, to the parts cost field in this query. Now, you've seen a few functions in previous videos. The isNull function works like the functions you've already met, with one major difference. The isNull function needs you to place two elements inside the parentheses. Firstly, a field or value, in this case the numeric field that contains the nulls, and secondly, a replacement value, in this case it's a 0. So what happens is, when you enclose the parts cost field inside the isNull function, what you've done is as if you've said, if the parts cost field contains a null, then use a 0 instead. This way, the isNull function will add a 0 instead of a null to the costs you're adding up, so the calculation will no longer fail for any record with a null in the parts cost field. Let's run the query. And I'll scroll down to the bottom again. Well, there are no nulls anymore. The isNull function has worked. To conclude this video, I want to show you how to filter on calculations. So firstly, I'm going to close the current query window without saving it, and then once I've done this, I'm going to open a new query window. I'm making sure, of course, that this is connected to the Prestige Cars database, and finally I'm going to paste in the new query. Oh, and of course I'm going to run the query. Before we look at the results, I want to explain how the query works. This query joins a series of tables in the from clause to ensure that we can return a collection of fields. Now, we need the make and model names for the output, but we also need the colour and line item discount fields, as well as the cost field, the repairs cost field, and the parts cost field and the transport in cost fields, even if these are only used in the where clause. So let's look at this piece by piece. The select clause adds the distinct keyword first of all, to ensure that there will be no duplicates in the output, and then displays the make name and model name fields. Then the action moves on to the where clause. The first line of the where clause is a fairly classic filter that wants to include only red cars where the line item discount field is greater than or equals to 1,000. Then the filter is extended with a calculation. This is what we're here to see. The second part of the where clause, introduced by the AND operator, calculates the gross profit, which you saw earlier in this video, and requests that only records where this figure is greater than 5,000 pass through the filter. And finally, the where clause is extended with one final aspect, an OR clause that accepts vehicles, whatever the colour or gross profit, providing that the repair cost and parts cost are both over 500. This is really quite a complex where clause. But the point that I'm making by using it is to say that you can use calculations in the where clause, and you write the rest of the where clause exactly as you would and did other filters that you've used in previous queries. Now, as this where clause is fairly complex, here's a schematic overview of how it works. Here you can see how the query is assembled. You have a first condition that says colour red and line item discount greater than or equal to 1,000. Then you have the first calculation where you're looking at the costs and the profit and making sure that these are above 5,000. Then you have an alternative condition, the OR clause, for the parts or repair cost above 500. Hopefully, looking more schematically makes the query clearer. Let's finish by reviewing the elements that you've seen in this short video. The first point is that yes, SQL can carry out arithmetical calculations. The 4 basic functions, plus, minus, division, multiplication, can all be carried out as if you were in a spreadsheet. Secondly, and to continue the spreadsheet image, calculations can be nested inside parentheses, just like the formulas you're probably used to writing in, say, Excel. And then, and this is important, you need to remember that calculations can be used in the select, where, group by, order by, and having clauses of a SQL statement. This may involve you repeating the calculation though if it appears in more than one clause. Finally, remember that null data can make a calculation return a null. So if you see a calculation that's giving absolutely no result at all, it probably means you have to dig into the data to find out which field is containing null values. So, before you go, just remember the following tricks and traps that you need to be aware of when you're doing basic calculations in SQL Server. Firstly, and probably self-evident, you can only calculate numeric fields and data types. SQL can't calculate text. Then an interesting point is that the order by clause is the only place in a SQL query that you can actually use an alias to refer to a column, providing you added this alias earlier in the query. And on the subject of aliases, remember that you need to add an alias to a calculated column in the select calls, or you won't see any column name in the output. And finally, and possibly most important, if in any doubt, use the isNull function. Wrap this around any field that you suspect has null data to prevent nulls having a potentially disastrous effect on your calculations. Thank you for watching. I hope that you enjoyed this short session and that it will encourage you to continue learning all about querying SQL Server. And remember, if you need a full and progressive introduction to querying SQL Server, you can always take a look at our books on this subject. These 2 volumes can help transform you from a SQL novice to an analytics maestro. To find them, just go to Amazon.com and search for Query Answers with SQL Server. Alternatively, visit your local bookstore. If you want to download the sample data that you saw in this video, as well as the SQL queries that we used, then navigate to www.tetraspublishing.com/SQL Server. Here you can find the sample data for download and practice querying it using SQL Server.